Stoichiometry uses molar ratios from a balanced equation to predict the amount of products a reaction will produce. It can also tell you how much of each reactant is needed for a desired amount of product. Stoichiometry is kind of like a recipe. You can figure out how much you need and how much will be produced by using that balanced equation. So our recipe here is for a turkey sandwich. This recipe for a turkey sandwich, although there's many different ones, is just 2 slices of bread plus 1 slice of turkey yields 1 turkey sandwich. It says that we have 10 slices of bread and excess turkey. Excess means extra. So we have more than enough turkey. We have 10 slices of bread. Bread would be our limiting reactant. It's limiting how much we can make. How many turkey sandwiches can you make? So you could do this one in your head, but we're going to set it up like we're going to be setting up all of our problems. 10 slices of bread. We have bread down here, and we're going to convert to sandwiches. To find my ratio of sandwiches to bread, I look at my balanced equation, or recipe in this case. 1 turkey sandwich needs 2 slices of bread. 10 over 2 gives me 5 sandwiches. And that would be my final answer with proof on how I got 5 sandwiches. One more together, it says I have 6 slices of turkey and excess bread. Well, I know that the bread's not affecting how many sandwiches I can make. So I have my 6 slices of turkey, and I'm trying to go to sandwiches again. For my ratio this time, I get 1 slice of bread, or 1 turkey, for every 1 sandwich. So I can make 6 sandwiches with that amount of turkey. Go ahead and pause the video and try these 2 on your own. Restart when you finish these 2. So for this first one, we had sandwiches, so knowing how many sandwiches I need to make, I can work backwards and say I have sandwiches on bottom and I'm trying to find bread. Well, just like before, there's 2 slices of bread for every 1 sandwich, so I would need 30 slices of bread. Number 4 was a little tricky. We had 2 starting amounts. So what you should do when you have 2 starting amounts is do 2 of our charts. So first, I'm going to convert bread to sandwiches. 2 bread for 1 sandwich, so I can make 7 sandwiches with my bread. And then I have 5 turkey. And 1 turkey is needed for every 1 sandwich. So I can make 5 sandwiches. Notice this problem didn't tell you who was excess. So we need to figure out which one is excess. I have enough bread to make 7 sandwiches and enough turkey to make 5 sandwiches. So I'm only going to be able to make 5 sandwiches. Sometimes people try to add these up, but that doesn't make any sense that I can make 12 sandwiches. I don't have enough bread to make 12. I don't have enough turkey to make 12. I can only make as much as the smaller one. So some vocab that you should have on your paper as well is turkey is my, again, limiting reactant. The turkey is limiting how many sandwiches I can make. Bread is excess. I have extra bread. When I'm done making my 5 sandwiches, I'll have leftover bread. So in class, we don't deal with turkey and bread. We have balanced equations and chemicals. So a balanced equation is just like that recipe. That's telling you that for every 1 molecule of nitrogen, it combines with 3 molecules of hydrogen to produce 2 molecules of NH3 or ammonia. But molecules are so tiny that we don't ever react as one molecule and 3 molecules to produce 2 molecules. We react moles of molecules. So we can also refer to those coefficients in moles. So according to that balanced equation, 1 mole of nitrogen combines with 3 moles of hydrogen to produce 2 moles of NH3. That's what we refer to as molar ratios. The molar ratio uses coefficients in a balanced equation. It's a ratio comparing the number of moles of one substance to another in a chemical reaction. For example, I would need 2 moles of aluminum bromide to react with 3 moles of chlorine. So I would need 3 chlorines for every 2 AlBr3s. Or I can think of it in the sense that if I have 3 chlorines, 3 moles of chlorine, I'm going to produce that same amount of moles of bromine if I have extra aluminum bromide. So the limiting reactant is the reactant that controls the amount of product that can be made in a reaction. It runs out first. So in this lesson, we're going to be talking more on the particle level and understanding what it means for stoichiometry and limiting reactants. So we have our equation that we saw a few minutes ago. It says that we have 6 moles of nitrogen reacting with 3 moles of hydrogen. So in this reactant box, we should have 6 nitrogens. But notice that nitrogen is diatomic, and it's represented with this circle. So I can't just have one circle. That's 1 mole of nitrogen. We're going to draw, every particle is going to represent 1 mole. So that's 1 mole of nitrogen, 2 moles of nitrogen, 3 moles of nitrogen, 4, 5, 6 moles of nitrogen. And again, there's 2 circles because it was diatomic. Then it says I have 3 moles of hydrogen, and hydrogen is represented with a square in this problem. Hydrogen is also diatomic. So I'm going to put 3 moles of hydrogen. So that's 1, 2, 3. When these react, they react in a 1:3 ratio to produce 1 N and 3 hydrogens. So the first time we solve this, we're going to go ahead and just start making our products. So I need 1 nitrogen and 3 hydrogens. And they should be attached in some format because they're bonded together. Whenever I draw my NH3, I'm going to cross out 1 nitrogen and 3 hydrogens. So I know I've used those up. Then I ask myself, can I make more? Yes, I have more nitrogen, I have more hydrogen. So I'm going to draw another one. So I've used 3 more hydrogens and 1 more nitrogen. Then I ask myself, well, can I make more? The answer is no. I've ran out of these squares, which were hydrogen. So hydrogen is my limiting reactant, which means nitrogen is excess. I could keep making molecules if I had more nitrogen and hydrogen. So all the ones that I didn't use need to come over here. So that's 1, 2, 3, 4, 5 that were unused. So that's what the container would look like after it was done reacting. You should have whatever products were formed and any of the excess reactant that was unused. I can also prove this with my equations. So I can say that I had 6 moles of N2, moles of N2, and I'm trying to see how many moles of NH3 I can produce. When you have moles over moles, we look at the balanced equation, and 2 goes with NH3, and a 1 goes with nitrogen. Multiplying across, with that amount of nitrogen, I could have produced 12 moles of NH3. I had 3 moles of hydrogen. Moles of hydrogen goes on bottom to cancel out, and I'm trying to find moles of NH3. From my balanced equation, I still have a 2 with NH3, and now I have a 3 with hydrogen. 3 times 2 is 6, divided by 3 is 2 moles of NH3. Out of 12 and 2, 2 is smaller, so I could only produce 2 moles of NH3. Notice I produced 2 moles of NH3. The nitrogen was my excess reactant, and that's why it's over here in the container. We could also have just looked at it and saw that if we have our balanced equation, it says 6 moles of nitrogen. So if I have 6 of these, and it reacts at a 1:2 ratio, then I should be producing 12 NH3s, which is what we calculated down here. If I have 3 moles of hydrogen, I react 3 moles of hydrogen, and I'll make 2 moles of NH3, which is what we calculated down here. Let's look at another example. So step 1 is, if they want you to draw the reactants and products, you're going to draw it out. So always look and see what is the formula. It's in 2, and I have 4 of them. Technically, the nitrogen and hydrogen would be mixed in the container, but it is easier to visualize if you keep them separated. Nitrogen on one side, hydrogen on the other side. Notice that those are all separated because it's not in 8, it's just in 2. And then we have 6 hydrogens. So that's 1, 2, 3, 4, 5, 6. So I'm going to start making NH3s, as many as I can. So 1 circle and 3 squares. 1 circle, 3 squares. I can keep going, so 1 circle, 3 squares. When you're crossing out your circles, make sure you finish out a compound before moving on to the next one. I still have some of both, so 1 circle, 3 squares. I can keep going. So in this case, I still have nitrogen left over. So my limiting reactant was hydrogen again, and my excess is still nitrogen. So to answer the question, I can produce 4 moles of ammonia. If I didn't draw it and they just wanted to know how many moles of ammonia, I could say I have 4 moles of nitrogen, moles nitrogen to moles NH3. I have 2 NH3s for every 1 nitrogen, so I can make 8 moles of NH3. And then I had 6 moles of hydrogen. Mole hydrogen, mole NH3. And I have 3 moles of hydrogen for every 2 moles of NH3. So it's 12 divided by 3, that's 4 moles of NH3. Notice we produced 4 moles of NH3. So both ways work. It just depends on, are they giving you boxes where you have to draw the reactants and products? Or maybe just the reactants are given and you have to figure out what the product box looks like, or the products box is given and you have to figure out the reactants? Or are you given the words and they just want to know the answer? All right, so we have a new equation this time. Go ahead and pause the video and draw your reactants. Restart when your reactants are drawn. So this time you had 4 moles of aluminum, and aluminum is not diatomic, and aluminum is the circle. So we have 4 circles, and they should all be separated since it's not diatomic. And then we have 4 moles of oxygen gas. That is diatomic, and that time oxygen is a square. So 1, 2, 3, 4. So we have our 4 oxygen and 4 aluminum. just looking at my balanced equation, I need more aluminum to react than oxygen. So I'm going to guess that my aluminum is going to be my limiting reactant since I need more of that to react than oxygen. So let's start building our products. Go ahead and build as many products as you can. Restart when you have your product box done. So in this case, you should have had 2 aluminum and you should have 3 oxygens. So 1, 2, 3. It doesn't really matter, again, how you're putting those together as long as you have 3 squares and 2 circles touching each other. So that was 2 circles and 3 squares. Then you should have drew another one. So another square, 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 and 2 circles. So yes, my aluminum is now ran out, so my aluminum was my limiting reactant. And then this is excess, so I should draw that in the product container as well. Make sure that you're bringing over your excess reagent. Okay, so now go ahead and figure out how you would solve it showing your work. Restart when you have your work, proving that this answer is correct. So you have 4 moles of aluminum, mole of aluminum, and we're converting to mole of aluminum oxide. 4 moles of aluminum for every 2 moles of aluminum oxide. That's 8 divided by 4, so that's 2 moles of aluminum oxide. And then we do the same thing with our oxygen. We have moles of O2 and moles of aluminum oxide. From the balanced equation, 2 aluminum oxide for every 3 oxygen. So that's 8 over 3, or 2.67 moles. The smaller amount is 2, so that's how much I can actually make. And whoever I started with to produce that smaller amount is always my limiting reactant. The other one is excess. Okay, this one, go ahead and figure out your reactants. Restart when you have your reactants box done. So you should have 7 aluminum. So 1, 2, 3, 4, 5, 6, 7. And then you should have 3 oxygens. So 1, 2, 3. Go ahead and pause the video and now figure out your product box. Restart when you've done your product box. So you should have used 2 circles and 3 squares. Two circles and 3 squares. And now I have 3 circles left over. So since my circles are left over, then I have limiting is oxygen this time, and I have excess aluminum. Go ahead and pause the video and now prove that with some work below. So 3 moles of oxygen. Moles of oxygen to moles of Al2O3. 2 Al2O3s for every 3 oxygen. 6 divided by 3, that's 2 moles. And then 7 moles of aluminum. Moles of aluminum for moles of Al2O3. 2 aluminum oxides for every 4 moles of aluminum. That's 14 divided by 4, or 3.5. This one's my smaller one, And I started with oxygen, so that's my limiting reactant, and this one's my excess reactant. All right, last one. This one is a little bit different because I gave you the products and I just want to know what were the reactants in this box. So for this one, you could go about it a couple of different ways. The easiest way is I have 3 of the O2s. That means that must be my excess reactant, which means limiting was aluminum. So I can go ahead and draw those over here because those weren't even reacted. Then I've got 1, 2, 3, 4, 5, 6 squares. 6 squares would be 3 more oxygens. And then I've got 4 circles. So that's 4 aluminum. I also could have said that I made 2 aluminum oxides. In order to make 2 aluminum oxides, I would have had to have 4 more aluminums. Oh, there's my 4 aluminums. And I would have had to have 3 oxygens. Those are my 3 oxygens that I needed. So those 2 columns were actually used, and then that column was excess.